This appeared to be a retro session, so I'd like to continue 1970s theme, namely it's an old new feature in Mathematica 8, which I'm going to talk about. Usually you don't work with the raw kernel, but occasionally you find yourself launching it for maybe some quick dirty calculation, or just I personally keep a small terminal window at the bottom of the screen just to have a powerful calculator. Also, sometimes you might want to use debugging, or use it for debugging, or maybe just to see how the kernel behaves versus behavior, and to compare it with the behavior in the front end. So sometimes it's needed, and unfortunately it was kind of overlooked for years. Let me show what I mean. Okay. All right. So here's the terminal. Here's the kernel running in a text mode in the terminal, and that's how it used to be for many years. Okay, and you can input some text and evaluate that. Everything goes fine until you made a typo. At which point you say, okay, I'm going to fix it, or I'll just correct it. So like this. So you're going to correct it, and you say, okay, I'll just go move the cursor back, and I'll just change the bracket. But oops, that's the moment of frustration, because you don't know what to do here. What happens is that it's a very basic interaction of the kernel with the terminal. Basically just reads the characters and displays them on a screen without doing anything more sophisticated. And so all these things that are displayed are basically it's a sequence of characters, or some kind of controlling sequence that tells the terminal, in particular this terminal that I'm connected to, I'm using, which is generated by the buttons you press, but the kernel doesn't know what to do with it. So that's how it used to be. Also, so and you see that these characters, or if you do like that and evaluate, these characters are interpreted literally by the kernel. So now I think it thinks that there is an open bracket somewhere, and so it asks for more input. And if you press another new line, it basically discards the input. So that's basically, so the idea is, the main task was that this somehow needs to be improved, because, well, this is not a good thing. And usually in connection with this, you recall an interface in Unix that became standard and which exists in many shells, which is based on the readline library, which allows you moving cursor back and forth, edit, and there are other nice features. Windows is slightly different in the sense that the DOS window, or the command line interpreter in PowerShell, it provides you with some features already, and you might not suffer this much as the Unix people. But that functionality is also kind of limited. So, and in fact, it is self-contained, so we cannot really add anything to it. So that's why this project appeared. Now let me show the new functionality that is now exists in version 8. Now it's for now it's just it's not very sophisticated. It's also basic, and now it behaves pretty much the way you expect it. So same things. You can evaluate. Now if you type something, you can slide the cursor back. You can delete characters. You can insert them. You can evaluate. There is okay. So let me show the. There is currently some keyboard shortcuts that are built in, but they don't have to be. Currently, they are hard-coded, but there is a mechanism for defining them for defining them. So it's pretty much what you would expect in the normal terminal, like Control A. I'll showing it here on the terminal. So Control A moves the cursor in the beginning, so you can add more. And you've noticed that if you add more, then the input gets redrawn. You can jump to the end and add more like this, or to the beginning. Now the backspace obviously delete, but there is also, you can delete the characters after the cursor, and apparently everything gets redrawn. Now you can also delete to the end of the line, which is sometimes useful. Oops. Okay. Yeah. So that's the input. Yes. Uptown. So there is a history. So that's your input, and then you can go back and evaluate that. So that's basically. And also, okay. So also, I mentioned this. If you press new line 2 times, the input gets discarded, which I think it's kind of unnecessary, because you may want to have a string which contains several new lines. Why wouldn't you have that? And yes, so now you can insert any characters there. Okay, so that's basically basic features how it behaves now. Okay, so my basic goal was to fix the Unix command line, and at the same time not to damage too much the Windows behavior. Why it would affect the Windows behavior is because Mathematica is cross-platform, and if I want to extend the behavior, if I want to fix that and add more features, I'd rather do that. I'd rather make it available on all platforms. So this behavior is implemented in a standalone library, which is cross-platform. So it is provided on Windows, on Mac, and on Linux. The library is loaded only when needed, and maybe that's your case when it doesn't work. Only if needed, or only if it can be loaded. In other words, if your computer is missing some required things, then it falls back to the old behavior. So that's why I need to take a look at that. Okay, so cross-platform, there's abstraction layer. It creates some common denominator of. It uses operating system APIs, which is completely different. So it creates some kind of uniform interface on which there is a code that there's a common to all platforms. I mentioned that standard on Unix is a read-line library, which almost all software uses. Unfortunately, the read-line library is a GPL license, which means it cannot be used in projects which are not open source. So, but even then, it wouldn't make much sense to use it, because that library is very much Unix, and it uses Unix system calls throughout the library. So even if I use that, I would have to refactor it quite seriously. So it made more sense just to start from scratch and do something similar, which is what has been done. Also, the library knows that it is called from the kernel. In fact, kernel passes some functions to it for use. One of them is, so the library has access to the parser, so it can check syntax. And also, if you don't type anything, there is a loop that allows processing asynchronous events like scheduled tasks or others. So in that sense, it plays nicely with the kernel. So now multi-line input is pretty much what I showed you. Is that your input is not limited to 2 lines. It can contain many new lines or other things. It also knows that if you have an open square bracket or open parentheses, it will wait for closing. It will ask for more input until you close that. And in that respect, this Control G or abandoned line input becomes important, because if you input some code in the command line and then you don't understand why it doesn't get evaluated, and you would rather just start from scratch, then you just abandon the input and re-enter it. So that's quite useful thing. Okay. Now it interacts with the terminal, so it can query its dimensions, which made available to the kernel. You can see that here, that if I evaluate, so the input stretches all the way to the window, to the right edge. 12. Okay. What's not implemented? If you resize the window, then currently the geometry is not updated. So I hope to fix that, but maybe not. It's not that important. So the kernel eventually it knows about the screen, the window size. Now on Windows, it uses standard Windows Console API, which is pretty much standard on all Windows computers. On Unix, it's more complicated. It requires nCourses library, which is installed by default on pretty much all computers nowadays. And term info database, which is also standard, also installed or expected to be installed there. And then if they're not available again, then you don't have this functionality, and you fall back to the old one. What are these libraries? So nCourses is a library that basically allows all control of the Unix terminal to move cursor, draw characters, and all that. And term info, maybe I'll just show the next slide. So in the old behavior, when I showed you that when I pressed arrow buttons, arrow buttons generate a sequence of ASCII characters or sequence of some codes. And the terminal is expected to interpret that. And the kernel is expected to pass it to the terminal. However, they were interpreted literally. They could not be treated as a sequence of control characters unless I somehow tweak the terminal. So that's what I say here, that it must be set to a specific state, a raw state, which means terminal by default comes with some functionality. It allows you to, for example, it waits until you enter the whole line and press enter, then it returns the whole line, and it reacts on some shortcuts like Control-C. It thinks that it is special code that sends a signal to the process. We don't want any of that. So a raw state, that means that no keys have special meaning, and that means that anything that is pressed on the keyboard, I have to take care of it myself in the code. So I have to implement something that makes the behavior. And the characters are not echoed automatically. That's also good, because for arrows, you don't want to display all the sequences. So characters are displayed. I should be able to display characters only when they should be displayed. That's the reason that the terminal is in some kind of raw state. Now, nCourses is a library to control the terminal. And it is used, well, I don't use it in the ways it's typically used. Typically, it's a library that takes over the whole terminal. I can just demonstrate you how it works here. Let's see. what's that mean one? Okay, so I'll start some program that takes the whole screen, it erases everything, and it draws its own stuff all over. It can control and can draw anything on a screen. However, we don't want that, because if you quit, you have an empty screen. And what I would expect is something which behaves like interaction with the shell. That means you type here, but you see what was previously typed. So here and cursors is used only. It's a very small subset of functionality that's used. I control only so-called input region, which starts with the input with the prompt and below. So it's one line or maybe two lines. Okay, now terminal. I'm talking about Unix terminal because Windows are kind of quite standard. So terminal, you can query what the terminal is, and Xterm is pretty standard. Now you can query. Now every terminal understands its own system of commands, which it's happy to tell you, or that's what the database is for. And this command will tell you, it queries the term info database for Xterm entry, and it gives a list of commands, which is looks like garbage, but they interpret quite nicely. For example, this command, which is called CUF1, defines a sequence of codes, and you may recall that is pretty much what was printed here. So that's what keyboard sends to the terminal when the arrows are pressed. So this CUF1 is the command to move cursor one step forward, and likely, and I think this one is to move up, and so on. Okay, so basically I query these commands, and then can control the terminal. Some terminals may lie about these capabilities. In other words, they say that, okay, I'm an Xterm terminal and I support these commands, but if I send this command, nothing happens. That means it's broken. And another PuTTY, which is quite popular Windows client, actually lies slightly about it also. Another more sophisticated terminals, they lie even more. So for that, functionality may not work, and that maybe need tweaking. But for standard terminals like this, I checked it actually works on various computers. Also, another thing to keep in mind that once the kernel waits for input, so the terminal is in the raw state, and if for some reason kernel crashes, the terminal is still in the raw state. So, and then you may see that your input behaves weirdly, or it doesn't print anything, or it prints in different parts of the screen. So there are ways to reset the terminal. It's reset command, which let me show you. It basically just returns it to original state. Or there is STTY which is some magic incantation which does pretty much similar thing. So that's just to as a means to not to panic. Okay, what about internal? So this functionality, it seemed to be simple. That okay, if I press an arrow key and just move the cursor, and if there is a character, then delete it and maybe print another one. But it appeared that there is some irreducible complexity to this. For example, let me show you. For example, here so you type, and then you can return, and then you can type more, and it is redrawn. So like that, and that happens until you reach the end of the screen. What happens then? And yeah, so that means I have to keep track of the width of the terminal. Also, if I keep entering, I get another line. So that means I have to keep. I need to keep some information about how many lines I have and where the cursor is, because if I move the cursor, I need to know where to insert. And if I insert, you see that it wraps, which means I need to, well, so there is some kind of structure that I need to keep. And also, if you see, if I'm at the bottom of the terminal, it also scrolls up. So there is some kind of functionality that is kind of connected. That's now the way it is done here is there are two separate editor systems. One is just the buffer editor, which is whatever you type, it goes into buffer, and when you press enter, it gets returned. But it always like that. So what's new here is the screen editor, which basically is responsible to all what's drawn on the screen, which does line wrapping, which keeps track of how many lines is in the input, where the cursor is, and what to do with how to shift the characters and all that. That's this way of separation also allows me to have freedom in the way that how characters are displayed. So if there is an unprintable character, I have a choice to display it or not to display it, or maybe to display it as whether that's a single sign on the screen, or it may be just a sequence of ASCII characters, and so on. So that's a good feature. Of course, so for you will not notice that, but that gives me some infrastructure for. So that's basically for having various features added quite painlessly. Now, the structure that keeps track of what is displayed on the screen is also somewhat complicated. It has character cells, which know not only about characters but also about different attributes and all that. So that gives me also some leverage. It uses double buffering, means that whenever you press a character, it's not so the screen does not blink. It does not redraw. It's not redrawn immediately. It's redrawn only when it's convenient. Also, it's not redrawn completely, but also only parts. These are common features for all terminal applications because often you connect to another computer on a server somewhere, and the connection may be quite slow. So you need to be aware that the bandwidth is limited, and this setup actually works quite nicely. Now, key mapping. There is a whole system that any key code any key that's pressed on a keyboard generates a key code. On Windows it's one way, on Unix is another way, but that doesn't matter because then the system just basically maps every key to a particular function that gets implemented. And currently they are hard-coded, so it's basically a list of assignments, but ideally they should be, these assignments should be read from the config file, so you should be able to reset to whatever you like. And there are some keys that are different on Windows and Unix. There is some different behavior there. One of them is, so like on Unix, if you press Ctrl-D, it deletes the characters unless it's an empty line, at which point if you press Ctrl-D, then quits the kernel. And on Windows it's a different character. So that's pretty much what is currently is done. There are some features that have been requested immediately that were planned. One of them is persistent history, which means that once you type commands and then you quit the session, next time you come in, you should be able to recall whatever you typed before. That's a common behavior, for example, in Unix shells, and it's also common in Windows. So that's one thing. Then history search means that you don't need to scroll using arrows to scroll the history. You may want to search for a command that maybe was executed like 100 entries before. Thing that is, I think, maybe one of the most important is to add support for characters which are not not ASCII characters, basically. So if you have a non-English keyboard and you commonly type on your native language and you name files using non-Latin letters, so that should be supported. Command completion, also a common feature. However, here it's now here's a room for improvement, because now we should be able we could be context aware, which means if you're just typing on the command line, then you press tab or some other key and you want to complete, apparently you might want to use some Mathematica functions. But if you are in a string, you may want to use something else. You may want to complete with maybe option name, or if you are inside the function which needs first argument is a file name, maybe you want to complete with the file name which exists in the current directory. So it's a good feature if it's implemented this way. Now mouse selection, copy paste. I'm not sure if it even worked on Windows the way it. So basically, you should be able to just select like this on the screen. Yeah, select characters on the screen and paste back in the command line, which is quite convenient. It worked differently on Windows and Unix. So I hope to unify this into some kind of convenient behavior. Another request for feature was that you should be able to skip larger chunks of input, like words. User-defined key mapping I already mentioned. That's basically it's a file that is read when the kernel starts, and then you redefine the keys the way you like. And there's another configuration, like to specify how it behaves with respect to history search and other things. So these are features that blend. So that's pretty much it. And please try and report if you notice something. Okay.